Welcome back, everyone. Our next session describes a business continuity application developed at INL. The name of the session is how cross-sector infrastructure dependencies can negatively impact your critical operations. Mike Hoover is our speaker. Let me tell you a little bit about him. Mike has 6 years of experience as a software engineer, and for the past year, Mike has been the program coordinator for the all hazards analysis framework developed in the Infrastructure Assurance and Analysis Division at INL. Mike fulfills both product owner and software engineer roles on his team and guides the technical software development of multiple projects based on the AHA framework. Recent implementations of this framework include a mission continuity and critical infrastructure analysis application deployed to the Department of Homeland Security's CLAN network, integration of software bill of materials, SBOM, methodologies into the AHA framework, and a presentation of AHA and SBOM at the Industrial Control System Joint Working Group Conference in September of 2021. Today, Michael will be discussing the essential function analysis capability for business continuity. We call that EFAC-BC, and providing a demonstration of its capabilities. Michael, thank you for joining us, and please proceed. And I may interrupt from time to time if you've got great questions in the chat to make sure you can see those.
Awesome, thank you, Sherry. Just want to verify that my screen's coming through for everyone.
It is.
Awesome. Well, like Sherry mentioned, I am Michael Hoover. I am the program coordinator for the All Hazards Analysis Framework here at Idaho National Laboratory. And the focus of my presentation today will be on the essential function analysis capability, business continuity. And what I'd like to do is kind of give a brief history of where we came from with this application, as well as give a technical demonstration of the application in real time. So with that, the items that I'd like to cover today will be taking a brief step just to help you understand why it is that we came up with the essential function analysis capability, and kind of walk you through the steps that we take at INL with the all hazards analysis framework, and then we can open up some time for some Q&A as well. So when we start talking about the essential function analysis capability, it is a knowledge management system that is focused on functional critical infrastructure dependencies, as well as essential function continuity tracking. So it's taking both the critical infrastructure, the actual facilities that are performing your essential functions, but also taking a look at that abstract continuity layer of how your essential functions might be interrelated with one another. But like I mentioned, it is built upon the all hazards analysis framework that we have been developing at the Idaho National Laboratory for the past 6 years now. And with that is part of the Infrastructure Assurance and Analysis Division here at INL. And so we have many other project teams within IAA that are similar to the All Hazards Analysis Framework, but ultimately what we're trying to focus on is how can we help our customers secure and understand their critical infrastructure dependencies. So as we dive into actually what we're trying to do with EFAC and with any product of the AHA framework, we really are just trying to reduce the impact that disruptive events actually have on your organization. And this is done through prior planning of those key infrastructure and resources, but then also identifying those mission critical processes and their dependencies, like I mentioned before. When we say mission critical in this context, that's mostly because of our development of this tool was mostly within the federal government with contractors like the DoD and DHS. So mission critical, I feel, translates pretty well just to critical operations of your business, whether however that may define for you. But overall with this, what we're trying to do is reduce that risk to your organization and improve your recovery time. Just on a knowledge management basis, the ability to transfer that knowledge from one individual to the next is the key process within any of our applications. And so as your organization changes over time, as people leave, people join, we want to make sure that there's a common framework of understanding for these types of activities. And like I mentioned before, we want to make sure that any mitigation investments that you make are actually data driven, that you're not saying, oh, I guess we'll put a backup generator here. We actually want to have the ability to say, yes, if we do put a backup generator at this location attached to this facility, we will see this kind of improvement to our resiliency. And then also identifying those single points of failure or those assets or group of assets that have far-reaching impacts. The thing that we really point to at this point as well is understanding the second and third order effects of a disruption. It's very easy to understand, okay, if the power station goes down, connected infrastructure loses electricity. But what is the second, meaning the next hop over, and the third, meaning the hop after that, of connected critical infrastructure that may occur? And so all of that kind of comes together. And what I want to demonstrate in my presentation as well is how we can actually use EFAC as a tool to have a additional accuracy in our tabletop exercises, meaning that we can play what if scenarios more easily and get more instantaneous feedback in those kind of disaster planning efforts. But ultimately, for approaches of this kind, I do need to note that our target stakeholders really are of the medium to large organizations that have assets distributed over a large area. When doing critical infrastructure analysis, if your organization is contained within a single building, it's very easy to say, okay, we get our electricity from here, we get our finished water from here, and there's not much in terms of cascading impacts that you can demonstrate as much as you could with organizations that have multiple assets over a large area. But ultimately, because it is a knowledge management system, smaller organizations can still benefit from the aggregation of that knowledge into a single application. It's just that when we start doing the functional critical infrastructure side of things, that's where medium to larger organizations definitely benefit more. So ultimately, we boil down our approach of any product of the all hazards analysis framework into two distinct areas. And the first is before the disaster, and then second is after the inevitable disaster occurs. And so in green, our stages of prepare and mitigate is that pre-disaster sort of area. That what we want to understand is gathering all of these critical infrastructure and essential function information together into the knowledge management repository. But then we can also begin to do those what if scenarios of understanding, hey, what mitigations could we actually put in place to increase our resiliency? But also, once those disasters or disruptive events actually occur, we can also use EFAC and AHA related tools to respond and recover. What kind of situational awareness or other activities can we do to respond to the disruptive event in the moment, but then also recover as we devolve to alternate locations for operations to continue, or other resources and other commodities that we need to manage in the event of those disruptive events. To take a jump back to then where all hazards analysis and EFAC has come from, really the basis for all hazards analysis came from laboratory directed research at the Idaho National Laboratory. But immediately after its creation and initial capability set, we began interfacing with several federal partners like we had mentioned before. The main one that I'll point out at this point is actually the National Risk Management Center. And if you were able to attend yesterday's conference, I believe it was Mara Wynn of the NRMC's Coordination and Planning Division, mentioned that they were using national laboratories for part of their efforts. And I can confirm that that is with the all hazards analysis framework that they're using to do that work with national critical functions and their risk architecture efforts. And so, NRMC is also utilizing AHA related technologies, not necessarily EFAC itself. The main component of Department of Homeland Security that has been utilizing our EFAC application has been the Office of Operations Coordination under Department of Homeland Security, as well as a couple other partners that we have within the DoD, specifically with the United States Air Force. So we have plenty of federal experience with creating this kind of knowledge management tool, but only recently did we actually move into the state as well as the private areas for the essential function analysis capability. And so the application is different from what we have deployed to the federal partners, but essentially the methodology is the same. We're still introducing that same kind of critical infrastructure and essential function knowledge management system, but specifically applied for state and local, or I should say private entities as well. And so we do have experience with a couple of state emergency management divisions, as well as a private operator telecom company called Strata Networks. And we can dive into maybe their example a little bit more later on. So now actually getting into the methodology that the all hazards analysis framework and EFAC takes into account. First, I'd like to start out with that infrastructure side of things. And so the key component or the key thing with the all hazards analysis framework is this idea of a generic dependency profile, meaning we want to understand the various types of infrastructures and we want to understand what their dependency profiles are. And what this allows us to do, or what AHA allows us to do, is dynamically create those facility models. Facility type models. So in our example that I have on screen here, you'll notice at the very center is a water treatment plant. And so when we talk about the dependency profile of a water treatment plant, we can understand that yes, it needs water for it to purify, but then also there is the need of electricity as well as some chemical dependencies for proper operation of the water treatment plant. And so we can create this generic profile so that anytime that we encounter a water treatment plant in real world data, we have a basic understanding of like, okay, where do you get your water? Where do you get your electricity? Where does your water go once it's treated? We can begin to make those kind of, have those kind of approaches with each type of facility type. But then once we actually have those profiles and we start connecting those profiles together, we can then start to see, as I mentioned before, the second and third order effects that connected infrastructure types may have. Once again, the simple example that I can demonstrate here on the screen is if we are aware of a disruption to a power plant, the first order effect would be, yes, there's a loss of electricity to the hospital in the region. However, the second and third order effects that we might not be aware of would be the cascading impact of electricity no longer being provided to a substation and electricity no longer being provided to our water treatment plant. So because of loss of electricity at this water treatment plant, there also is the potential for a finished water loss at the hospital as well. And so understanding all of those complex relationships that infrastructure pieces might have within a given region can help our hospital be more aware of the impacts that the power plant going down might have or being disruptive might have. Ultimately, at the laboratory as well, we're always focused on data set development. And so we're using everything from structured data sets, from unstructured data sets, to even things like spatial heuristics that allow us to build and understand not only the assets themselves and their locations, but the dependencies that they have amongst other items within that region that they're in. And so from this, this is the infrastructure side of things, and we can I can demonstrate later on with a toy case that I have of data later. But moving on to the essential function layer, like I mentioned, our initial methodology was developed with the federal government in mind, specifically with Department of Homeland Security. And so our originating documents for this approach are the Federal Continuity Directives number 1 and 2. And from this, DHS puts it out very plainly that we have a very structured approach to essential functions with national essential functions, the 8 or 9 that are there, that then decompose into primary mission essential functions, which decompose into mission essential functions, and finally decompose into essential supporting activities. And ultimately, all of these mission essential functions are tied to components within the DHS. So Customs Border Patrol, ICE, TSA, all have their responsibilities of mission essential functions. And so what our approach with essential function analysis capability is understanding when we get to that mission essential function or that essential supporting activity layer, what are the assets and systems that are required for those essential functions to operate. And so not only can we understand the primary locations that those essential functions are performed, but we can also understand the devolution or the alternate sites available for those essential functions. The example that we always give is with CBP doing border patrol operations on, for example, on the southern border. If there was a disruption that affected one of their facilities, they very likely have an alternate facility that they can devolve to continue operations until the matter is resolved. And so all of this is helping us understand how not only the organization is responsible for their mission essential functions, but how cross-organizationally there might be essential functions that are interdependent on one another. So ultimately, what the key areas that we're trying to improve with any type of this analysis, as you can see, is our recovery time objectives, or RTOs, as well as our maximum tolerable downtimes, or MTDs. And we have several other types of assessments and analysis that we can perform to say, hey, here's how resilient your mission is with its essential assets and essential systems. Well, like I said, this is very well and good for the federal government, but we wanted to take the same methodology and apply it to a private business instance. And so, like I mentioned before, with the Regional Resiliency Assessment Program, we did deploy the essential function analysis capability to Strata Networks, which is a telecom company in the Utah, Wyoming, Colorado region. And so what this approach taught us is that we can still apply that federal continuity directive methodology, but specifically applied to businesses. And so rather than having very structured essential functions, we broke it out and let the analyst or let the users of our application decompose their essential functions however they want. And there are other key changes that we've made to the methodology that are specifically applied to EFAC, business continuity. And from this decomposition and from our partnership with Strata Networks, we were able to identify their over-reliance on propane for devolution activities. That if the part of their operations were disrupted, more often than not, there was a reliance on propane to continue operations at their devolution site. And so they were able to identify, hey, that's probably not a good idea to all be reliant on the same source of fuel for these devolution operations. With that, I'd like to move into the demonstration of the tool itself. I feel that it makes it a little bit easier to talk to. And just making sure that chat and comments are good. Okay. And for that, then I will go ahead and switch over to my, so this on this screen that you're currently viewing, this is an internal deployment at INL that we have of the essential function analysis capability, business continuity. And for the demonstration today, we'll be using just a notional data set of assets in the Idaho region so that I can briefly talk to and explain the capabilities of the application, as well as demonstrate very simply what kind of analysis we can do with the tool. So with this, what you're currently viewing is the map interface of the application. And so for this test case that I'll run through today, what I'd like to do is, maybe in another life I wasn't a programmer. I actually became a businessman, and because of my name, I feel it's only appropriate that I started a industrial cleaning company. And so what I can do is come over to our organization tab and get a very brief breakdown of here's how I organize my industrial cleaning business. And so I can decompose my company into its various sub-organizations, and we can dive into how the essential functions of these organizations are tied to critical infrastructure. So with that, the next step that I want to kind of walk through is following very similar to my presentation is, let's walk through first the infrastructure side of things, then we can walk through the essential function decomposition, but then finally we can actually take all of that information together and run some simulation analysis on my infrastructure data that I have prepared. So the first thing then is that idea of a dynamic infrastructure model within EFAC. And so coming to our model page, we have a couple of different models that we'll be working with, but like I mentioned, all of these are dynamic, meaning that me, the user, not necessarily the programmer, can come in and say, I want to be more specific than just chemical manufacturing. Like I want to actually get down to the facility type that will allow me to model what this specific type of chemical manufacturing plant actually is. So right now what I'm looking at is a very generic model. If we come down to its dependency profile, we can see that of all of its child facility types, whether that be ammonia, chlorine, plenty of other chemicals that we can produce, I can get more specific as to what the dependency profile actually is for each of these facility types. And so I can begin to build and say, hey, in order for me to actually have a chemical manufacturing plant, I need obviously crude chemicals, dry natural gas, electricity, finished water, but then the output or the provider commodities that I can provide are listed on the right-hand side. And so these facility profiles, as you can see at INL, we have developed significant other sectors, specifically within electricity, within the oil and natural gas sector, as well as finished water. And so, you can build out these models, you can understand how commodities are being passed amongst facilities, but you can also understand the commodities themselves. And so clicking over to the dependency types model, I can decompose and understand all of the different types of natural gas. Natural gas is pretty broad. There's dry, wet, sour, everything in between, but you can understand what those different classifications of those commodities are. So not only can you get specific with the commodities being passed through, but you can also understand the sub-facility layer. And so what I mean by the sub-facility layer is facility types are the general approach, or what you could normally fit inside of a building, or is a building. And so when we get to sub-facility types, what we can begin to understand is the subcomponent structure that often appears within a facility type. And so we can take the example of understanding backup generators. Within communications, we can understand things like network routers, access points, server racks, as well as HVAC fuels, and honestly, once again, whatever it is that you want to model within the assets themselves. And so this kind of takes a particular point within the framework as well, is that this is where we're starting to see a lot more cyber integration within our framework, where we can say, hey, what if a cyber disruption disrupts our server, or cyber disruption affects our network router? Then we can start to see impacts to other critical infrastructures at that level as well, not only at the broad level. And so finally, then we can also model our threat and hazards that affect our facilities. And the general model that I have here is just an example that we can not only model how natural hazards like blizzards or hurricanes might affect our assets, but we can also model how cyber threats like a DDoS attack or phishing might affect assets, might disrupt our operations. So with that, then, this is all just the abstract model side of the framework and of EFAC. Now I'd actually like to dive into the facilities themselves. And so the first view that I'll just demonstrate real quick is just a grid format in which I can load all of the assets that I have loaded into the application. And this is just to demonstrate a quick view of, hey, here are the facilities, their types, as well as other details we can view about it. And so I'm going to focus in on this demonstration center, which is tied to my business. But what this allows us to do is see a brief overview of this facility type as it relates to all of the different areas of our application, where we can see basic information, as well as you can see the sub-facility information that I've provided for this demonstration center. So we have, of note, we do have a server rack that's performing and providing us, application or systems. Then we also have some backup electricity means, and we can dive into that later. But as well as that information on here, we can also begin to understand the critical dependencies that are linked to this facility. And so this is just a graphical view of those dependencies that I've created of commodities flowing into this facility. We have other items that I can discuss here, but for now, what I'd like to do is now jump back to our map interface, where we can view that same information that we had viewed on the grid interface, but now on our geospatial interface. So I'll go ahead and load this pre-saved query that I have, but essentially this will load those facilities as well as their dependencies onto the map interface. And we still have the grid view down below here that has that same information. I'll go ahead and load up our legend here as well so that we can get a better idea of the types of facilities that we have loaded onto the screen. We'll discuss this lonely facility over here later and focus mostly on the eastern part of Idaho here that we have zoomed in on. And so the color dots, the user can actually modify the color themselves for whatever they want the colors to represent. But as you can see, the different colors represent various facility types, as well as if you click over to dependency types, we can understand the flow of commodities amongst those facilities listed here. So once again, I'll just kind of dive in and take a look at our demonstration center where we can see that same information that we saw on the facility model, but now with that geospatial enhancement to it, where I can click through as well and see things like the dependency list, as well as the sub-facilities that we saw before. So just to briefly kind of walk through the toy case that I've built for the demonstration today, I have my operations of my business kind of located in this lava flow area just so that it's notional and not actually representative of anything real. But of the real assets that are on the map, we do have a natural gas pipeline that's running through the region and then making a fork both to the west and to the northeast, as well as some electrical dependencies both generated from the city of Idaho Falls, as well as from a wind farm that I have located nearby my area of operations. And so from this, we can begin to understand the critical infrastructure dependencies that occur within our within my own test cases data set. And so the key thing that I want to point out here is that, yes, I can create those models for my infrastructure assets that I am in control of, but I can also create and model the infrastructure assets that I am not in control of. The term that we use is outside the fence infrastructure assets. And so not only can we create dependency profiles for the infrastructure assets that we are in control of and we are aware of, but we can also start to build out those dependency profiles and actual data for things outside of our control that can nonetheless still impact our own critical infrastructure. And so the very basic example of that is if this natural gas pipeline were to be disrupted, there would be eventually an impact to our chemical manufacturing plant listed here. So with that, then this kind of brings us to the critical infrastructure side of things explained. Now I'd like to jump into the organizational and essential function decomposition layer. And then finally, we can discuss how those two layers interact and what kind of analysis we can derive from it. So to start explaining the essential function decomposition, I'll start heading back to our organization tab, where I have a very brief, very simple decomposition of my business. But the division that I want to focus on would be our sales division. And so we want to understand and we want to walk through the critical pieces of infrastructure that are needed for the sales division to do its job. So we can, understand the basic scripts just as we want. So any other type of organs or other entities within the sales division can be modeled as well. But for each item that you see on the left-hand side here, they are specific for the rest of the tabs, meaning that we can create information detailees or dossiers specific to each organization. And so just kind of walking across the tabs that are available on the page here, we can understand the essential functions that this organization is responsible for or has a role in. So very simply, we see an essential function to sell product, but we also can see that the sales division supports the distribution of our components. We can see the facilities that are tied to this organization's essential functions. So you see our demonstration center that we viewed previously, as well as a couple of warehouses. We can break down the leadership of this division. So there's an understanding of who's in charge, who's the next in charge. But we can also create a point of contacts. And so this is an area that we can add point of contact information to say, hey, if I need to know about sales division, I can get that contact information right from the application. Next up would be key performance indicators. This is definitely more for the oversight of others so that we can say, hey, what is this organization actually doing to do better? Or what are the areas that this organization is working towards in understanding? But finally, then the thing that is definitely the focus of the application is this idea of documentation and plans, where the user can upload specific documentation of things like a business resumption plan, cybersecurity plan, emergency preparedness plan. And I mentioned before, this is specific to the organization. So if I click away from the sales division, I get a separate interface from that. And so I can upload not only these plans, but any other kind of continuity information that might be relevant. And so at any time, if I want to understand what the physical security plan of this organization is, I can simply click that download, and that is downloaded to my own computer for me to view, but is held as a knowledge management repository by the application. So jumping into then the essential function area of the application, I'm going to use this other view real quick just so it makes a little bit more sense. But essentially the same way that we can decompose our organization, we can also decompose our essential functions. So like I mentioned before, this is kind of a breakaway from the federal continuity approach and more towards a business approach where I can take my high-level business essential functions and decompose them into more specific and more relevant, pieces of information. So I have a high-level function of manage, but I've chosen to, say, okay, really what I'm doing is providing cleaning agents to customers. And so I can say, okay, that can be decomposed into the aggregation of components, into actually producing the components, and then finally distributing and selling those. So once again, as we saw before with the organization tab, we can then make that tie to essential functions. And so what I'll do is I'll dive into our essential function view for this specific essential function. And where we can see, like I mentioned before, specific information about recovery time objectives, the status, as well as kind of the continuity criticality level of this essential function. Similar tabs to what we saw before, but what I'd like to focus on for this demonstration is this idea of facilities. And so with facilities, this is actually saying, hey, this is the facility that is needed in order to perform this essential function. So this really is where that jump from the infrastructure side makes it to the essential function side. And like I mentioned before, I can not only have the primary facility at which this essential function operates, but also have alternate locations that that this essential function could also be performed at, as well as the time that it would take to switch from the primary to the alternate. And so it doesn't just have to be a single alternate facility. We could have multiple alternate facilities for this essential function to be performed at. So with that, I'd like to then dive into the types of analysis we can do once we've gathered all of this information together. And to do that, I'm going to head back to our map interface here. And so the two types of simulation that I'd like to do or like to demonstrate with you all are first a simple, cascading what if kind of scenario, and secondly, a more built out and more customizable simulation type. And so for this first one, it is just a simple cascading simulation in which once started, this will just turn all of our facilities and assets green as an operational. But what this allows us to do then is say, hey, let's take that example from before where we want to understand how a disruption of the natural gas pipeline might have on our assets. So I'll go ahead and disrupt this facility, and in real time, it will calculate the cascading impact that it has downstream from that disruption. And so we'll see both on the graphical interface as well as the geospatial interface that both the northeastern branch and the western branch are impacted by this disruption, but also one of our assets within the lava flow area here also has a significant impact because of the loss of this natural gas pipeline. So we can view this information in this format, but we could also view this information within all of the essential functions operating within this area. So this view that I have pulled up down below is now it's taking all of the information that we have based on the facility data and filtering that to essential functions. Whereas you can see our essential function of producing cleaning agents is the only one that is being disrupted, meaning based on the simulation impacts that we've defined, here's the impact that occurs to our essential functions based on this data. So if I wanted to, I could go ahead and reset my simulation. And this time what I want to do is impact the actual electrical generation that's coming from the Idaho Falls hydroelectric facility. So once again, I can disrupt this. We can, say this, in this case, this might be a cybersecurity disruption or, whatever else. But once again, we can see both graphically and geospatially the impact that that disruption has, not only on the facilities themselves, but once again on the essential functions. So this time we see a much more significant impact to our essential functions in this region. And we can even dive further into understanding, okay, what is the disruption that's actually occurring? So if I wanted to understand the disruption here, I can expand and see that our chemical manufacturing plant is disrupted by this electricity going down, but we don't have any alternate facilities, which probably is pretty bad on our part. Whereas if we wanted to look at the aggregation essential function, it is impacted, but we do see the alternate location is still operational at this time. So this time, what kind of analysis we can do is say, hey, if this asset were to go down and these conditions were to actually occur, and it was going to be more than 4 or 5 days time, it would be worth it for us to devolve to our alternate location. In this case, it's the asset that we saw on the west side of Idaho for operations to continue. So this, like I mentioned, is a very simple approach, very what if type of scenario. But next, I'd like to actually demonstrate what happens when we take the time to plan and to actually understand what these disruptions might actually have effect on our assets.
Hey,
And
Mike.
Oh yeah, what's up?
Yeah, just real quick, I wanted to make you aware that we've only got about 7 minutes before a hard stop, and we got a couple questions that people have put in the chat, and I can just read those to you. And I don't know if you want to finish the demonstration or take those now.
Yeah, let me just real quick finish the demonstration, then I can take those
Okay.
questions.
Okay.
So the advanced simulator, or the simulator that allows us to actually control and make more precise engagements, I'll go ahead and just run a quick scenario here that's also doing that kind of electrical disruption. And so what this actually provides is now we don't just see a single update, but we actually have a timeline of impacts that occur for the assets that are taking part in the simulation. And so I can, click through the timeline here to kind of get the on-off stages for each of the assets at any given time of the simulation. But what I'd like to point out for this one is this inclusion of the sub-facility information that we have for our demonstration center. So starting out at the initial state, everything's running hunky-dory. When we have that initial impact to our hydroelectric facility, we can see graphically as well as on the map that there is that cascading impact. There are a couple of assets that are disrupted, but our demo center is still operational because we have that secondary source of electricity from the wind farm. But in this example, what if the wind farm were to go down as well? We still see that there is an impact or a disruption to our demonstration center, but our server is still operational due to the backup generation sub-facilities that we have for this facility. And so, not only can we have that high-level information of how those commodity flows are affecting operations, but we can dive into the sub-facility layer of these facilities and see that, okay, our UPS takes the load, then our backup generator switches on. It provides about 10 hours of capability, at which point the UPS tries to keep the load up, but ultimately we have a disruption to our server at day 5, hour 16 in our simulation. So as kind of my finishing thought before answering your questions is, I want you to imagine, once we've gathered all of that information for your organization, and you can see the impacts that occur to not only your critical infrastructure, but your essential functions, but then also understanding, hey, what are the types of backup generation, in this case, sub-facilities that we can add to increase our resiliency for your essential operations. And like I mentioned before, we can do that not only for the critical operations or critical infrastructure inside the fence, but outside the fence as well. And so real quick, just the example that I would give is that the natural gas pipeline, if we were to build it out, we would see that it originates in the Utah region, but there actually is another branch that heads westward across the Snake River Valley here. So if we were to have that infrastructure data in place, we'd be able to see, hey, if the Utah area is disrupted, not only would the Eastern Idaho natural gas chain be disrupted, but also the Western chain would be disrupted as well. So not only would our primary locations for our essential functions be disrupted, but also our alternate locations would be disrupted in that scenario. And so the ability for the essential function analysis capability to hold and store all of that data really gives that kind of analysis product or that analysis capability for you to understand how all of these critical infrastructure disruptions will affect your essential function and their operations. So yeah, thanks everyone for taking time with my presentation. I'll be happy to answer any questions that you have. Sherry, did you, you said you had?
So Mike, I don't know if you can see the questions in the Q&A, but the one question that Gina Albanese asks is, does this work just for the continental US or will it work for Hawaii, Alaska, and other territories?
Yeah, so currently we have coverage for the entire United States, but in the very short term, we also are planning internationally. So you can track assets in any part of the world, track infrastructure assets in any part of the world.
Okay, and then how is the AHA tool envisioned to be shared and ultimately used with state and local governments and private sector infrastructure, or is it intended for Fed only?
Yeah, so the current status is we're undergoing processing for commercialization license of the EFAC business continuity application. And what that will be is and how we've done it in the past is actually deploying this technology to either an internal network or to a cloud-based environment, whereas the customer then controls access of the application. So any data that you put in is your data. You don't have to share it with anybody else that you don't want to. And so that's the approach that we've taken so far with that. And I guess tangential to that question as well is, like I mentioned before, INL is always focused on that data set development. And so any interest that you have in developing your infrastructure knowledge base, INL would be very interested in joining in that effort and helping you build out not only your own infrastructure, but also that outside the fence infrastructure as well.
Okay, and then how does this work for transportation networks? Similar type of analysis? Has this been done yet?
Yep. And so with that, what we do is we have a specific type of dependency, which is called a transportable dependency. And so we do have in our own critical infrastructure data set, we do have the rail network mapped out completely. And what we can understand then is what types of commodities can be transferred over the rail network. And so very similarly, if there's a disruption on the rail network, then all those different types of commodities that can be passed over the rail network are also considered disrupted at that point. But yes, we do have the capability to model that.
We have about 30 seconds left here, Mike, and there's two more here. Is there a relatively simple way to upload interconnected infrastructure, say across an electric utility, data from a spreadsheet to start the mapping process?
Yep, we do provide capabilities within the application to ingest that structured type of data, whether it be a spreadsheet for both the critical infrastructure as well as dependencies. It is just a matter of getting it in the right format for the upload to occur, but we do have that bulk upload capability.
All right,
Hey,
so we'll
Mike,
try one. I'm sorry, go ahead.
There's a few more questions in the chat. Perhaps what you could do is go into the chat and maybe answer those questions for the folks who posed them.
Of course. And if anyone else has any other questions, please feel free to reach out to my email address listed here or to Ryan Hruska, who's the program director for the All Hazards Analysis Framework.
And Mike, one question you definitely will want to get to is how to access the tool. Can't find it on the INL website. So,
Yep. And I think the only answer I can give for that is currently under review for commercialization license of the product. And so if you would just wanted to reach out to me to let you know when that when it's available for public use, I'd be happy to stay in contact with you.
All right, so Mike, if you could take a look at those chats and the Q and A's, that would be fantastic. And then if you could stop sharing your screen, that would be great.
Yep.
All
Thanks
right.
again for your time.
Thanks a
Thanks,
lot,
Mike.
Mike. Nice job.
Appreciate it.